Hello and welcome to the course on counting sort, a non-comparison sorting algorithm in which the array will be sorted based on the counting the number of occurrences of each distinct element. Let's move on and learn the intuition behind the counting sort with an example. Suppose we are given this array. Firstly, we need to find the maximum element. This is crucial step since we must establish the size of a counts array or auxiliary array and allocate enough space to accommodate all the elements in the given array. The counts array which we will create is used to keep track of the frequency or counts of each element in the input array. Therefore, the size of the counts array is determined by the maximum element as it represents the upper bound of values we need to accommodate. A counts array or an auxiliary array is created with a size equal to the maximum plus 1. This is because arrays are zero indexed, indicating that the initial element is located at index 0. Therefore, for example, if you have a list of values ranging from 0 to 10, you would need an auxiliary array of size 10 plus 1, because array indices typically start from 0. By allocating the counts array with the size of maximum plus 1, we ensure that there is enough space to accommodate all possible values from 0 to the maximum. Move on and initialize the array with zeros. Then, in the next step, we must count the occurrences of each element in the input array and update the counts array accordingly. Go to the input array and start from the leftmost element. The first item is 2, and we must update the counts array or auxiliary array accordingly. It probably seems a little bit confusing, but keep in mind that we update the occurrences in the counts array at the index corresponding to the value of the element in the input array. In simpler terms, we would like to keep track of how many times each element appears. Therefore, each index in the counts array corresponds to a unique value of the input array. Now let's move on with the next step. The next element in the input array is 1, and then go to the counts array to update its occurrences. Do the same process for the remaining elements, and each time when you encounter an element in the input array, then update its occurrences in the counts array. As it is observed, the element having a value of 3 has been spotted again. Therefore, this time we will update the counts array and we will increment its occurrences. The process is straightforward. Once this step is accomplished, we must move on to the next step, which involves summing up elements with their predecessors, or in other words, we must find cumulative sum of the elements and transforming the counts array into a cumulative sum array. Let's calculate the cumulative sum, and I will explain shortly why we use this cumulative array. At the beginning, there is no predecessor, therefore go ahead and update the counts array to 1. The predecessor of the next item is 1, so update the counts array accordingly. For the next item, the predecessor that we already calculated was 2, therefore 1 plus 2 is equal to 3, and update the counts array again. Do the same process. It is simple and straightforward. Now we have everything for sorting the input array. But to give you a deeper understanding about why we calculated the cumulative sum, let me give you some examples. Please keep in mind that each index in the counts array represents a unique element, and the value at that index represents the count of occurrences of that element in the input array. Let's change the perspective of the counts array by making the indices a little bit bigger. Each index in the counts array or auxiliary array signifies a distinct value, and the corresponding value at that index in the counts array denotes the count of occurrences of that particular element in the input array. Now let's describe few examples before moving on to the next step. In the counts array and at index 1, the value is 2. Let's translate it very simply. It says that the frequency of element having the value of 1 is equal to 2. More specifically, it says we have two elements in the input array that their value is 1 or less than 1. Let's check this fact. Go to the input array and inspect the elements. As it is observed, we have two elements with the value of 1 and 0. Let's discuss another example. Go to the counts array and at index 3 the value is 6. In simpler term, it says there are 6 elements in the input array that their value is equal to 3 or less than 3. Let's evaluate this fact. Go to the input array and as it is observed, there are exactly 6 elements having values of 6 or less than 6. Now let's jump to the counting sort steps, and in the last step we create an output array for accommodating sorted elements. Then set a pointer starting from the rightmost element. 3 is the rightmost element. Then go to the counts array and point to the index 3. At index 3, the value is 6. Simply put, the element having the value of 3 must be placed at index 5 of the output array, not index 6. I know that this might be a little bit confusing, but remember that I talked about the fact that it says we have 6 elements having a value of 3 or less than 3. And as we discussed earlier, indexing starts from 0. Therefore, with the fact that there are 6 elements, we need 6 slots, in which the index starts from 0 and ends with 5. Meaning that when we have 6 elements, therefore the last possible slot to accommodate an element will be 5. Therefore, in this example, the correct index of an element having a value of 3 is at index 5. But before putting the element at its correct position, we also decrement the value corresponding to index 3 of the counts array. By decrementing the count of a value in the counts array, we are effectively freeing up space for the elements having the same value. For example, here we have 3 elements having a value of 3. Therefore, we have to decrement the value corresponding to the index 3 of the counts array to accommodate the next element which has already a value of 3. Now let's move on and place 3 at index 5. The next element is also 3. Therefore, go to the counts array and decrement the value corresponding to the index 3 to accommodate the next element having the same value of 3. So we place the next element having the same value of 3 in the index 4 of the output array. The next element is 8. Go to the counts array and decrement the corresponding value of the index to find the correct position just as we did for the previous elements. Place 8 at index 7 of the output array. Again, we encounter another element having a value of 3. Go to the counts array and decrement corresponding value and place 3 at index 3. The next one is 0, and in the counts array, we decrement the corresponding value, which is the occurrence of 0, and then put 0 at index 0 of the output array. Do the same process for the remaining elements and place 1 and 2 at their corresponding indices in the output array. As you can see, the array is sorted now. I tried my best to make counting sort as simple as possible. I hope you enjoyed learning, and please feel free to share your feedback and any question you would have. Thanks for watching this video.